In previous day, we have learned the software development lifecycle model. Today, we will continue that and we will start from a review of the previous model, that is classical waterfall model. We know that classical waterfall model is sequential in nature and it is a top-down approach. There is no iterations, there is no back process. That means if you have any problem in the previous slide, then in previous page, then you cannot move to the previous one. And it is a sequential in nature. That means if you finish the previous stage, then you only can move to the next stage. And this is the simplest and most intuitive approach that we have found in the software development lifecycle. Though this type of lifecycle is not possible nowadays because there are so many difficulties or disadvantages available, and so we need to improve our this type of models, and but all those models, all the later models are based on the idea of this classical model. That's why we need to learn this model. This classical model has so many advantages, like it is easy to understand, and even by non-technical persons can understand this waterfall model. And each phase has a well-defined inputs and outputs. We can easily understand which is the output of this phase, which is the output of that phase, such a way. And it is easy to use as software development proceeds. Obviously it is easy to use. If one phase is complete, then we will only start to the next phase. There is no confusion between these phases. How much we have to develop in this phase, how much we have to develop in that phase, there is no confusion. The phases are not also overlapped. And it helps the project manager in proper planning of the project. So project manager can easily plan that how the project will move on. And there are lots of disadvantages. The biggest drawback of waterfall model is that it does not support iteration. The iteration means while designing the activities are being carried out, the new requirements can come up anytime. Similarly, when product is being coded, the new design and new requirement problem may arrive in the middle of the project. So in the waterfall model, we cannot move back and we cannot rectify those problems into our software or project specification. Another disadvantage of waterfall model is that it is sequential in nature. One cannot start with a stage till the preceding stage is completed. We cannot start from the middle of the stage. This is the sequential in nature. And user have little interaction with the project team. Their feedback is not taken during the development. That when the development is going on, the user's feedback is not, the customer's feedback is not taken. So the customer's feedback is taken at the last of your project, when the project is completed. If in that time the customer gives you some changes, then you cannot process into your project. So these are the drawbacks. Another is customer gets opportunity to review the project very late in life cycle model, and because the working version of the product is available at the last of the software development life cycle. The model also has difficulty in accommodating changes in the product after the development process starts. So these were the problem we have found in the software development lifecycle model. Now we have to remove this type of disadvantages. We will introduce a new model that is called iterative waterfall model. Though the classical waterfall model is idealistic, we assume that no defect in introduced during any development activities in the classical waterfall model. But in practice, the defects to get introduced in almost every phase of the life cycle model. This is not real life scenario. In real life scenario, we can get many defects, many new requirements in every phases of the life cycle. The defects usually gets detected much later in the life cycle. For example, a design defect might go unnoticed till the coding or testing phase. It may be defined in the working phase, that is when the software has been prepared. The later the phase in which the defect gets detected, the more expensive is its removal. Why? Because when you get the in the last phase you get detected the problems, you have to rectify the software requirement specification, you have to rectify the design specification, you have to change the coding, you have to again test the whole project. So all these phases you have to go through the project in the waterfall. In case of waterfall model, if these are the if this type of problems found in the final stage. So once a defect detected, the phase in which it occurs needed to be reworked, redo some of the work done during that, and all subsequent phases therefore need feedback paths in the classical waterfall model. So we need a feedback path in the classical waterfall model, and this is the solution of the feedback path into the classical waterfall model, and we call this an iterative waterfall model. So here found that all the feedback paths goes from anywhere to anywhere, not the feasible study. The feasible study is not necessary previously if it not necessary in the next time if you found once that the project is feasible to you. So feasible study no need to get the feedback again. So all the other development stages are required to get the feedback path. From the testing, if you found any new requirement or any problems, then you have to go to the requirement analysis. You may go to the directly design, you may go to the directly into the coding. So these paths are called feedback paths, and these paths gets from the lower stage of the waterfall model to upper stage of the waterfall model. And in the classical waterfall model is an idealistic one since it assumes that no development error is ever committed the engineers during any of the life cycle phases. However, but in practical development environment, the engineers do commit a large number of errors almost every phase in the life cycle. These defects usually gets detected much later in the life cycle. Once a defect is detected, the engineers need to go back to the phase where the defect has occurred and redo some of the work done during that phase and the subsequent phases to correct the defect and its effect on the later phases. Therefore, in any practical software life development work, they need a feedback path. It is not possible to strictly follow the classical waterfall model. The feedback paths are needed in the classical waterfall model from every phases to its preceding phase to allow for the correction of the errors committed during a phase that are detected in later phase. And then the effort on a phase may require some rework later due to errors in that phase which were detected in the later phases. This necessitates rework in already completed phases. So the errors should be detected in the same phase in which they are introduced. For example, if a design problem is detected in the design phase itself, the problem can be taken care of much more easily than say if it is identified at the end of the integration, the system testing phase. Okay, the problem if you find in the design phase, it is better than if you find the problem into the integration system testing, because if you got found the integration system testing, the software has been already prepared, and if you get in the design phase, then the problem has been established to being prepared by coding or any other process. So the early stages, if you find the detect, is more helpful, more easy to rectify it. The rework must be carried out not only to the design but also to the code and test phase if you find the product problem or error into the system design or integration phase. The principle of detecting errors are close to its point of introduction as possible. It is known as phase containment errors. Iterative waterfall model is by far the most widely used model. Almost every other model is derived from the waterfall model. Almost every other model is derived from the waterfall model. That's why we can say that waterfall model is one type of idealistic model. When to use waterfall model? When requirements are well known and stable. If we understand that all the requirements are well known to the developer and they are stable, no one can change these requirements, then we will use this waterfall model. But in real life, it is not possible. When the technology is understood, when you understand which technology you will use into your project, then you can use the waterfall model. When the development team has experience with similar projects, if your development team has experience to working on the similar type of projects, and so they can easily understand what are the difficulties may arise, and they can rectify it in the early stages. So if all these type of requirements, all these type of constraints are filled, then you can only use the waterfall model. The next type of model is V model. So we have learned waterfall model, and we have learned all the difficulties. To remove the difficulties, we have added feedback paths in the waterfall model. The model becomes iterative waterfall model. Now the model we will learn the next model, that is called V model. This is the actual architecture of the V model. This model was developed to relate the analysis and design activities with the testing activities, and then focuses on verification and validation activities of the product. That the software lifecycle is looks like this. The dotted line here are the figure, dotted line here indicate that the corresponding phases must be carried out in the parallel. That means when you are doing project planning, then production, operation and maintenance are doing in the parallel. As in the case of the waterfall model, V model should be used when all the requirements of the projects are available in the beginning of the project. So V model are same when all the phases are to be done into the when all the requirements are fixed at the starting of the V model. So V model is one type of variant of waterfall model. It emphasizes on verification and validation. Validation means you are going to understand that we are going to looking that your project is going to according to your requirement or not. It is you are going to validate your project. And verification means that you are thinking that your project, you are going to looking that your project is doing according to your just previous requirements or not. So verification is done in each and every phase, and validation is done after completing the project and the system design, so system testing phase. V and V activities are spread over the entire life cycle. V and V means verification and validation. In every phase of development, testing activities are planned in parallel with development. So here we are finding that each and every phase the testing activities is done. How? When you are going to requirement specification, the software is not going to develop. So how the testing will be done? And keep in mind that when you are going to test something, then you have to first taking the idea that which value you will put the inputs, and which value you will get the outputs. So you have to find these use cases, you have to find these test cases actually. So when the requirement is going on, requirement specification going at the parallel time, you can create this type of test cases. So after finishing the product, you just run these test cases and get the output is actual as you're expected or not. So the test, so when the development phases is going on, the testing phase also in parallelly going on. So when the detailed design is going on, you have to find out the test cases that what value you have to put into the design phase and which should be the outcome. When the high level design or integration high level design is going on, in that time you have to think that if you integrate, how to integrate your modules so one by one, and how to test those modules one by one. Now what should be the test cases available for this integration testing. So starting from early stages of software development, the V model emphasizes the planning for verification and validation of the software. Each deliverable is made testable. For each and each deliver is testable, easy to use obviously. V model is weakness is it does not support overlapping of phases. It does not handle iteration or phases. That means there is no iteration. Look, if there is a problem into the detailed design or coding you have found, then you cannot move back into the requirement specification and you cannot rectify your problems. It does not handle iterational phases. It does not easily accommodate later changes to requirements. It is same. Does not provide support for effective risk handling. So there is no risk handling process into this V model. So the advantage of the V model, you can say that it is easy to use. It focuses on the testing of all the intermediate phases, intermediate products. It focuses on the testing mainly, and the plans for verification or validation activities early in the life cycle, thereby enhancing the probability and building the errors free and good quality of software, etc. So when to use V model? Natural choice for systems requiring high reliability. When the embedded control application satisfy critical software, in that time we will use the V model. If all the requirements are known upfront at the first stage, all the requirements are known, in that time we will use V model. If solution and technology are known, that means here we can use the V model where in that case also we can use waterfall model. Okay, here are the advantages. It is easy to use and plans for verification and validation activities early in the life cycle. And there are some disadvantages, that it does not support iteration of phases. This model is used for system in which the reliability is very much important. That is, the system developed to monitor the stages, state of the patients, etc., etc., etc. And the software is mainly in case of embedded system type of software, this model is normally used. Embedded system type of software where the requirement is clear at the first of the stage. So we have learned the waterfall model, iterative waterfall model, and the prototype model. This model is also similar to the prototype model is also similar to the also the stages are similar to the waterfall model. It is a derivative of waterfall model. We derived some ideas from the waterfall model and prepares a new model. Before starting the actual development, a working prototype of the system should first be built. So in the prototype model, first build the working type prototype, and A prototype is actually a toy implementation of system. It is not the actual system. It is there are limited functional capabilities, low reliability, and inefficient performance. So prototype means, suppose if you like to prepare a project, then there are some more than say 10 to 15 pages will be there, and you just prepare all those pages but do not write anything into the pages, rather than the give the outlook of your pages. So this is called prototype. When the prototype is built, prepared, finally approved by the customer, then you throw out the prototype, and this prototype will be removed from your project, and you will start from the new stage of the prototype model. So this is the prototype model. First we have to communication or requirement gathering. After gathering all the requirements, we have to prepare a quick design of the software, where all the functionalities are not available, and it is the actually the outlook of the project. And then you have to build the prototype. If when the build the prototype, the customer evaluate it, if customer refine some requirements, and then you again design it and then build prototype, and this process is going to into the circle or iteratively until or unless the customer accept your prototype. When the customer accept your prototype, actually what have happened, in that case you have gathered all the requirement from your customer. Okay, when the customer accept your prototype, that means you will gather or you will collect all the requirements from your customer. So this type of prototype model is helpful when the requirement from the customer is not clear to the developer. When customer do not understand what is their requirement and do not clarify their requirements to the developer. So this is prototyping model. And when the acceptance has been done from the customer, you just throw out this prototype and start from the design phase, that is system design phase, through the DFD, through the ERT, etc. After finishing the design phase, all the next successive phases are similar to the iterative waterfall model. So design, then implementation or coding, unit testing. Sometimes the coding and unit testing phases are called implementation, and then the testing, then the maintenance. So these four phases are iteratively like the iterative waterfall model. So often a customer defines a set of general objectives for software, but does not identify the detailed input processing or output requirements. In other cases, the developer may be unsure of the efficiency of the algorithm, the adaptability of an operating system, or the form that human-machine interaction should take. In these cases and many other situations, a prototype paradigm may offer the best approach. Prototype is a partial development product. It is used for developing a mock-up of product and is used for obtaining user feedback in order to refine it. Further, the prototyping paradigm begins with communication with the customer. The software engineer and customer meet and define the overall objectives of the software. The prototyping iteration is planned quickly, modeling in the form of quick design. The quick design actually focuses on the representation of the software aspect of the requirement aspect of the software that will be visible to the customer end user. The quick design leads to the develop or build a prototype. The prototype is deployed and then evaluated by the customer user. Feedback is used to refine requirements for the software, and the iteration occurs as the prototype is turned to satisfy the needs of the customer, while at the same time enabling the developer to better understand what needs to be done. If a working prototype is built, the developer attempts to make use of the existing program fragments or applies tools that enable the working programs to the generated quickly. So after accepting the prototype, that you have gathered all the requirements, and then you throw out the prototype and then go to the actual design phases. What is the reason for prototype? The learning by doing. That means it is useful where the requirements are only partially known. If the requirements are not clear at the first stage of the software, in that case we cannot prepare our software. So it improves the communication between the customer and developer. It improves the user involvement or customer involvement in the project, and it reduced the need for documentation. It reduced the maintenance cost also, as the customer gets understand the actual prototype, how it looks like, how it will handle it, so at the first stage of the requirement. It illustrates to customer the input data formats, how the data will be inputted into your project, what will the messages you will get from your project, and what should be the reports of your project, inactive dialogues, how appears those dialogues into the project. They examine It examines the technical issues associated with product development. So often major design decisions depend on issues like response time of hardware controller, efficiency of a sorting algorithm, etc. etc. These type of issues has been checked previously before going to develop your actual software. At the first stage, you can clear all those steps. Another reason for developing prototype is it is impossible to get it right the first time. At the first time, it is impossible to get it right. That what you have prepared, what you have done, it should be easily make good to your customer. So it is impossible to get it right the first time, and we must plan to throw away the first version. Obviously, this is an important problem in the prototype, that we must throw out the first version, that is the prototype. If we want to develop a good software, we have to need to develop the first prototype and then throw out it. So here is another type of here is the description. We have to start the approximate requirements, then carry out a quick design, then prototype is built using several shortcuts. These shortcuts might involve using inefficient, inaccurate, or dummy function. So functions are available, but they will not work. The details of the function will not work. A table lookup rather than performing the actual computation. So this prototype is one type of table lookup, but it will not work on the actual computation. The developed prototype is submitted to the customer for its evaluation. Whatever you developed, the customer will evaluate it. Based on its feedback, the prototype is refined. This cycle continues until the user approves the prototype. When the user actually approves the system, then you will gather all the requirements. The actual system is developed using the waterfall model, the next stages. So in the waterfall model, the detail of the communication requirement, quick design, build prototype, customer evaluation, refine requirements, these 5 stages in the waterfall model, we name that software requirement and requirement gathering and analysis. So that phases are divided here into these 5 stages. The requirement analysis and specification phase becomes redundant. That means the finally working prototype serves as an animated requirement specification. It incorporates all the users' feedback. So the requirement is gathered by incorporating the user's feedback. Design and code for the prototype is usually thrown away. However, the experience gathered from the developing the prototype helps a great deal while the developing the actual software. So this design will be throughout and the actual software is then going on. Even though construction of a working prototype model involves additional cost, you can understand that if you construct this working prototype, then it will involve the additional cost. Yes, it is, but the overall development cost becomes lower because the systems with unclear user requirements are cleared at the first. Systems with unresolved technical issues has been solved at the first of the project. Many user requirements get properly defined and technical issues get resolved. This would have appeared later as change request and resulted in incurring massive design cost. So if you have got any technical issue at the time of integration, and that issues have to be solved or identified and solved in the time of requirement phase, in the time of prototyping. So this may incur a additional cost, but actually the project is going to easy in the next stages. These are the advantages. The resulting software is usually more usable. The user needs are better accommodated. The design is of higher quality. The resulting software is easier to maintain. Overall, the development incurs less cost. And these are the disadvantages. For some projects, it is expensive. It is susceptible to over engineering. Designers start to incorporate sophistications that they could not incorporate in the prototype. So the advantages of the prototype is a partial product is built in the initial stages, and therefore customers get a chance to see the product early in the life cycle, and thus it gives the necessary feedback. Now new requirement can be easily accommodated as there is scope for refinement. So the requirements become more clear, resulting into an accurate product. So these were the advantages of prototype model. And the disadvantages: after seeing an early prototype, the user may demand the actual system to be delivered soon. User cannot understand that why we are going to develop a prototype by losing our time, by losing our money, and then you throw out the prototype and you are going to again start your project. If the user is not much technical person, then you will think that this is a bogus. If an end user is not satisfied with initial prototype, he may lose interest in the project. If the customer do not interested in your prototype, then he may not give you the project further. So in that case, you may lose the project. And the developers in a hurry to build the prototype may end up with suboptimal solutions. If the developer into a hurry of the prototype building, in that case there may be suboptimal solutions have been occurred and the project may be lost. This model should be used when requirements of the system are not clearly understood or are unstable. It is also be used if requirements are changing quickly into the software development model. So till now we have learned waterfall model, iterative waterfall model, V model and prototype model. The first three ones are those models where the requirements are fixed or stable at the first of your project. In that case, the software and the waterfall classical waterfall model, iterative waterfall model, and V model are best in that type of project. But if the requirement is not clear to understand to the developers from the customers, and the requirement is not stable or frequently changing, in that case, to fix the requirements and to give an idea of the software to the customer, it is better that you use this prototyping model. So this prototyping model is build first the prototype, then after the customer acceptance you throw out the prototype, and then you prepare the actual iterative steps of the waterfall model.